In this tutorial session, we are going to look at operators. There are 6 Python operators: AAC, LBB, assignment, arithmetic, comparison, logical, Boolean, and bitwise. The identity and membership operators are a subset of the Boolean operator. We are going to focus on the most used operators: assignment, arithmetic, comparison, logical, and Boolean. The purpose of an assignment operator is to assign a value to the variable name. Arithmetic operators perform a math operation on numeric values. A comparison operator is used to compare two values, and the logical operators combine statements that have a condition. Last but not least are the Boolean operators, which represent an expression that returns true or false. Let's start with the assignment operator. We have used the assignment operator since naming and creating a variable. It is the equal symbol that assigns a value. For example, course equals, let's say, Python step by step. This statement assigned Python step by step to course using the equal symbol. When it comes to an arithmetic operator, there are 7 operators. We have addition, subtraction, multiplication, division, modulus, exponent, and floor division. Recall in Python, there are 2 types of numbers. We have integers and floating point numbers. The integer is a whole number, and floating point numbers are numbers with a decimal. The arithmetic operators work on both types. Let's look at a few operators such as print, let's say 10 plus 3. We know the plus symbol represents addition, so the answer is 13. Yes, the console returns 13. Now I'm going to copy this statement and paste it 6 times. 3, 4, 5, 6. The second statement would be subtraction. We have multiplication. We have exponent. And there are 2 division operators: the normal division operator and the floor division operator. Last is the modulus, which is a percent sign. I'm going to run, and we know 10 minus 3 is 7. 10 times 3 is 30. And this here will be 1,000, because it would be 10 times 10 times 10. And this here division, there will be 3 and some decimals. And this here will be just the whole number of 3 divided by 3. And this here will be 1, because 10 divided by 3 is 3, and the remainder is 1. I'll talk about it again. Okay, so we see subtraction is 7, multiplication is 30, exponent raises 10 to the power of 3, then return 1,000. That's 10 times 10 times 10. We have those 2 division operators. The normal division operator shows 3.3 with 5 at the end. And the floor division operator is also known as an integer operator because it only returns the whole number. That's why we don't see a decimal. So 10 divided by 3 is 3. It does not include the decimal. Now, the last value is the modulus. That's when we divide one number by another number, then return the remainder. The remainder of 10 divided by 3 is 1. For all of these arithmetic operators, we also have augmented assignment operators. An augmented assignment operator is also known as a shortcut operator because it combines one operator with an assignment operator. For example, the first row shows a plus symbol and an equal symbol. There's a total of 13, but these are the main ones we just went over. we can also combine strings using an augmented operator. In the IDE, we have course equal to Python step-by-step. On the next line, I would write course equal to, plus equal to, and the value will be tutorial. When I print course, we're going to see Python step-by-step tutorial. Do you see what happened? It combined the first value with the second value. It's the same with addition operator and the other arithmetic operators. Now, we can write for addition, let's say 10 plus 5. We can write the print statement for addition. The interpreter will add 10 plus 5, which is 15, then assign 15 to the addition variable. Let's run. And as expected, the console returns 15. The long way of incrementing this statement by 5 is to write addition equal to addition plus 5. This is the long way. Now the shortcut of incrementing by 5 is to write addition plus equals 5. It's the same process. Now I'm going to print. And when I print, we know this statement is 15. Incrementing by 5 will be 20. And the last value would be 25. So I'm going to print addition and print addition again. Then run. And yes, we see it incremented by 5, 15, 20, and 25. There's something else I want to show you. It's the order of operations, also known as operator precedence. In math, it's called PEDMAS. Let me go to the next one. It's called PEDMAS, which is PEDMAS. That's parenthesis, exponent, divide, multiply, add, and subtract. It provides the order of how our program will execute the arithmetic operators. For example, let's say result is, what's a good number? 21 minus 1 times 10 plus 10. Looking at this statement, a person might think we solved this problem starting from left to right. But using PEDMAS, we begin with the parentheses. And that's equal to 20, 10 plus 10. Then multiply by 1. 20 times 1 is 20. Now we have 21. 21 minus 20 is 1. So when I run, the console shows 1. Good. That's it for assignment and arithmetic operators. Next, I will show you comparison operators. Thanks for watching, and I will see you in the next session. Cool. In this tutorial session, we are going to discuss two operators, comparison and logical. Here is a list of 6 operators. First is the equality operator, which is an equal sign for equal to. Then we have the inequality operator for not equal to, followed by 4 more operators. The greater than operator, greater than or equal to operator, less than operator, and less than or equal to operator. Each of these operators are used to compare 2 values, then evaluate both values. After evaluating the values, the interpreter will return true or false. In the IDE, we can write print, then compare our values such as 10 and 5. The comparison operator is placed in between both values. Something I learned from my kids with their homework, helping them. Alligator eats the bigger number. The comparison operator is the alligator. 10 is a bigger number. Therefore, this statement is true. Run, and bingo, we see true in the console. Let's compare some more values. How about print? 12 is greater than or equal to 34. Print. 1 is less than 1. Print 15 is less than or equal to 15. We can also compare strings like print Python is equal to Python. Also, let me put that back. Print Python. My typing is not going good this session. Python does not equal to Python. Okay, so now let's run. The console returns true, false, false, true, false, true. So we already covered 10 is greater than 5. So that's true. Next is 12 is greater than or equal to 34. And the console returns false. The alligator is eating the smaller number. That's why we see false. Next is 1 is less than 1. That's false because they are equal to each other. So 1 is not less than 1, it's equal to 1. 15 is less than or equal to 15. We see true because 15 is not less than 15, but it is equal to 15. So that's why we see true. The strings show false and true. The first set is false because they are not equal to each other. Python on the left has an uppercase P, while Python on the right has a lowercase p. Now, the second set of strings return true because they are not the same. Have you noticed something? The difference between 2 equal signs and 1 equal sign. Start out, it can be confusing because in math, the equal operator means equal to, but in Python, 2 equal signs means equal to. What helps me to not get confused is 2 equal operators in Python are comparing 2 values and asking if they are equal to each other. That's it for comparison operators. Now let's take a look at the logical operators. The purpose of a logical operator is to combine more than one expression. We can also say one conditional statement. There are 3 logical operators: and, or, not. And returns true if all statements are true, or returns true if one of the statements is true. Not returns the opposite. If the result is true, then not operator returns false. That's interesting, and I'll show you. In the IDE, we can print 100 is greater than 50, and 100 is greater than 34. The interpreter will evaluate from left to right. First, is 100 greater than 50? Yes, so that's true. And is 100 greater than 34? That's also yes. Therefore, both statements are true. So the console returns true. If I change one of these comparison statements, like 100 is greater than 50 to less than 50, then the result is false. As a result, we see false in the console. It's false because both of these statements must be true. For the OR operator, only one of these statements must be true. For us to see true, we will run. And bingo, the console shows true because the value that is true is 100 is greater than 34, although 100 is not greater than 50. Now, I have something else to show you, and that's the NOT operator. The NOT operator reverses the result. However, at this point, we have to be careful because our code can be confusing. For example, if I write NOT in front of 100 is less than 50, someone may think the code is referring to the complete expression, but it's only referring to 100 is less than 50. To refer to the complete statement, we must add a parenthesis in front of 100 and at the end of this statement. Now it's comparing 100 is less than 50 or 100 is greater than 34. So the code is saying this: is 100 less than 50 or is it 100 greater than 34? After running the previous statement, we saw true. Therefore, this statement will return false because not true is the same as false. Run. And bingo, we see false. Let's do one more statement and make it a little complex by adding and. 100 greater than 95. Do you have an idea what the console will show us? The NOT operator is referring to 100 less than 50 or 100 greater than 34. 100 greater than 95 is separate. For the AND operator, both conditions must be true. They are not true, so the console shows false. That's it for comparison operators and logical operators. Thanks for watching. Don't forget to connect, follow me, and subscribe. Plus, click the bell icon, and I will see you in the next session. In this tutorial session, let's discuss the Boolean operators. A Boolean operator represents two values, true or false. It evaluates a condition, then returns a value. The identity and membership operators are two types of Boolean operators. An identity operator is used to compare two objects, and the membership operator is used to test whether a value is found in a sequence. We see identity has is and is not. Is returns true if the objects are the same, while is not returns true if the objects are not the same. The membership operators are in and not in. In returns true if a value is specified in a sequence. Not in returns true if a value is not in a specified sequence. Let's start with the identity operators. Our objects are address underscore 1234 and address underscore 1238. The values will be inside of a list. First will be red, black, and white. I'm going to copy and paste so they have the same value. These two data types are a list of strings. If I hover address 1238, we see list with str inside of the brackets. It's a different data type than what we discussed in our previous video, comments and data types. The purpose of a list is to store more than one item in a memory address location. We see the same values are stored in a different objects. Therefore, if I print address 1234 equal to address 1238, we expect the console to return true because they have the same value. Now, as expected, we see true. When it comes to an identity operator, we are comparing the objects and not the values. Therefore, if I change equal to is, they have the same values, but they are different objects pointing to a different address. Since they are pointing to a different address, they are not the same. So when I run, we see false because the objects are not the same, even though they have the same value. Imagine two houses that are located right next to each other. They look exactly the same, but have a different address. One address is 1234, and the other address is 1238. Although they look the same, they are not the same because they have a different address. If I write the ID function, which returns the address of an object, hover the ID function, and we see it returns the identity of an object. This is guaranteed to be unique. Pass in address 1234, then print. When I print the ID for both objects, you will see that it will have a different address. Let's run, and the console shows a different value for each object. We see one of them ends with 7728 and the other one ends with 8240. Now, I'm going to copy and paste this identity operator and change it to be is not. Run, and we see true in the console because both objects are not the same. Now, we can make both objects the same by assigning one object to the other object, like address 1234 is assigned, the value is assigned address 1238. So now when I copy these other print statements and I paste them and run, look what happens. We see now they both have the same address memory location for both objects. That's it for identity operators. Now, let's take a look at the membership operators. Membership operators is a little different because we know they test whether a value is found in a sequence. So our variable will be message equal to I like Python. The sequence can be a string or it can be a list. We can test by writing something like print Python, followed by a membership operator, end. Is Python end message? Yes, Python is in the message. So when I run, the console returns true. The membership operators are case sensitive. So if I write print Python, not in message, we see true in the console because Python with a lowercase p is not in the string I like Python, because I like Python has an uppercase P. Thanks for watching. That's it for Boolean Operators, Identity, and Membership. Don't forget to subscribe and click the bell icon. Also connect with me on LinkedIn, follow me on Twitter and Facebook, and I will see you in the next tutorial session.